In this unit, we're going to be dealing with slope and writing equations of lines. You did this last year in Algebra 1, but we are going to review a little bit of it so we can use it again for this unit. So as a review, when we have slope, we have four different kinds of slope. We have positive, which is going up when we're looking left to right, negative, going down left to right, zero, and undefined. So those are the four different kinds of slope that we are using. When we look at slope from a graph, remember we are doing rise over run. So that means we are starting at point A and we're figuring out how much we need to go up and how much we need to go over. When I do this one, I am going up +4 and over +5. For number 2 though, my slope is a negative slope. So remember we get negative when we either go up and left or down and to the right. We're still going to count how much we go up and how much we go over. In this case, it's up 3 and over 6. But we need to always simplify our slope, and that simplifies down to -1/2. If we look at doing it with ordered pairs, remember the slope equation is y2 minus y1 over x2 minus x1. We got to make sure that we are lining things up correctly. So if I look at problem number 5, we have point A and point B. I'm going to say that point B is my x2 and my y2, and A is my x1 and my y1. I'm going to write it all out. Remember, if we subtract a negative, that's the same thing as adding. So 6 minus -2 is the same as 6 plus 2. Again, we always need to make sure that we are simplifying. Number 6, we're going to use that slope formula again. We get 10 over 5, and when we simplify that, that's 2 over 1, but that over 1 doesn't really mean much when we write out our equation, so we can just say 2. Couple more examples with this. With my number 3, my slope is going just straight up and down. It's this line that has N and M on it. Sort of hard to see, but that is an undefined slope. Remember, when it's straight up and down, it's undefined. And number 4 is an example of a zero slope. If you want to, you can still count the rise over the run, but we always know that the straight up and down is undefined and straight side to side is 0. Number 7 and number 8, again, we are using our slope formula. When I do this one, I have 9 minus 9, which is 0. Anytime we get 0 on the bottom, that is an undefined. We can never divide a number by 0. Number 8 is an example of a zero slope. So I have 0 on the top. We can do 0 divided by 7. 0 divided by any number is just 0. So those are the differences with finding slope with our slope formula and from a graph. We also need to talk a little bit about slope-intercept form. So if you remember, slope-intercept form is y equals mx plus b, where m is our slope and b is our y-intercept. And we always write equations of lines like this. So if we look at our graph for number 1, we see that they gave us 2 different points. Remember, those points can help us find our slope. And then our y-intercept is wherever we are crossing our y-axis. So for this problem, my slope is 2. I'm going up 2 and over 1, up 2 and over 1. And my y-intercept is -3. When I completely write that out, I'm going to replace m and b in the slope-intercept equation and write y equals 2x minus 3. Number 2 can be done the same way. So my slope is -4/5. Remember, if I have a negative line, my slope needs to be negative. And that y-intercept is -2. So the equation of the line is y equals -4/5 x minus 2. Number 3 is the same exact way, but in this case, my y-intercept is the origin. Remember, origin is the point 0, 0, so my y-intercept is 0. When we write that out, we could write plus 0, but we don't have to. So when I write y equals negative 1/3 x, that plus 0 is there invisibly, so it's implied. If we look at the next set of problems, we can graph each line based off of our equation. So again, we can pull out the slope and the y-intercept. And then we're going to start by plotting a point at -1 and counting up 5 and over 4. For number 5, remember there's a -1 in front of my x, so negative x is -1. Again, we're going to start at that y-intercept of 6, and to get -1, I'm going to go down and to the right or up and to the left. Lastly, we have number 6, which is 2x. That means we have a y-intercept of 0 since there is no other number that has been written. We're going to start at that origin and we're going to count up 2 and over 1. So that is our y-intercept and our slope-intercept form. We can also talk a little bit about standard form. So if you remember, standard form is ax plus by equals c. A, b, and c are just our numbers, and x and y are on the same side for this problem. When we see problems like this, we always want to put it into slope-intercept form, so we're going to solve for y. If I look at problem number 7, to solve for y, I simply just need to subtract x from both sides. When we write it out, we always want to put the x first and then that other number, so it's in y equals mx plus b form. For number 8, we have a little bit more that we have to do. So we are going to start by subtracting that x term over, but we also need to divide by the number that's in front of our y, by that coefficient. So we're going to divide everything by 2. When we do that, we want to simplify each term if we can. -5 over 2 is going to stay the same. We don't want any decimals in these problems. But -2 divided by 2 can be simplified to -1. Number 9, we're going to do the same process. Again, when we simplify, -2 divided by -4 can simplify down to 1/2. And then 28 divided by -4 can simplify to -7. 10, 11, and 12 are the same exact way, so I'm just going to show you those. I do want to point out for number 10, when I have a -y, that is not my final answer. Y always has to be positive. So I do want to divide everything by -1. Dividing by -1 just makes everything its opposite sign. We can graph these problems as well. We're still going to put it in y-intercept form, and once we have our slope-intercept form, we have our slope and we have our y-intercept, and we can graph from there. With our 0 and undefined slopes, we can write those equations of lines as well. So if I have a undefined line, that means I'm crossing my x-axis. If I'm crossing my x-axis, I'm going to write x equals, and then whichever number I'm crossing at. So in this case, I'm crossing at -1. Remember, if it's straight up and down, my slope is undefined. For horizontal lines, I am crossing my y-axis. It's parallel to that x-axis and going through the y-axis. So I'm doing y equals, and then wherever I cross that point. In this case, it's y equals 3, and my slope is 0. We can graph these as well. If I am starting with y equals 4, that means I'm going to cross my y-axis at 4. So I'm going to count up 4 and draw a straight line across. X equals -2. I'm going to go to the x-axis and go to -2 and draw a line straight up and down. For y equals 0, that is going to look like it's just on the x-axis, but we really are on our y-axis. We're crossing our y-axis. Last thing we need to go over with slope and writing equations of lines is what happens when we are given a point and a slope. So we're still going to write it in slope-intercept form. We're always going to start with y equals mx plus b, and then we're going to replace our m with the slope that they gave us. In this case, it's 2. To figure out our b, our y-intercept, we're going to take our point and plug in our x and our y. So in this case, 1 is our y and 4 is our x. And then we're going to solve for our b. Once we solve for b, we are going to go back to our slope-intercept form, and we are going to replace m and b. So our final answer is going to be y equals 2x minus 7. We're going to do the same thing for number 2. So again, always starting with y equals mx plus b, and we'll replace our m with 1/2. We're going to plug in 2 and 4 for x and y. When we solve, we get b equals 3. So y equals 1/2 x plus 3 is our final answer. 3 and 4 are the same way, so I'm just going to show you those answers. Again, always solving for b and writing our final slope-intercept form. We can also do this when we are just given 2 points. The only difference between these problems and the problems we just did is we have to find our slope using that slope formula first. So we're using y2 minus y1 over x2 minus x1. When I do it for this problem, I get that my slope is -2. And then I do everything the exact same way. So I'm using y equals mx plus b. I'm replacing my m with -2. When it comes to replacing our x and our y, you can pick either point. I chose the first one, but you could easily do the second. No matter what, you should get the same y-intercept and the same final equation for your line. 6 is done the same way. We're going to find our slope using that slope formula. Remember, we always need to simplify, so we don't want to use 3/9. We want to use 1/3. And then we're going to plug it in. When I have a fraction slope, I always try and look for which point might be the easiest and might help cancel out that fraction. In this case, I chose the second point, 3, -4. When I solve for b, I get -5, and my final answer is y equals 1/3 x minus 5. So that was looking at slope and writing equations of lines, and we're going to use that for the remainder of the unit.